This is problem 4.57 in AOPS Introduction to Number Theory. Ben, Fang, and Venetia are playing a game in which a card number 2, 3, 4, 5, 6, 7, or 8 is stuck to each of their foreheads, so that each player can see the other two numbers but not their own. Joey walks in and observes that the three numbers are not all different, and that the product of the three numbers is a perfect square. How many of the three players can now deduce the numbers on their forehead? Okay, so the key here is that the three numbers are not all different, meaning the three numbers are either, so they might all be the same, or two of them are the same and one is different. And that the product of the three numbers is a perfect square. So the perfect square one is more important right now, so we can factorize out each of these numbers. So 2 is just 2 to the power of 1, 3 is 3 to the power of 1, 4 is 2 squared, 5 is 5 to the power of 1, 6 is 2 to the power of 1 times 3 to the power of 1, 7 is 7 to the power of 1, and 8 is 2 cubed. Okay, so we want a perfect square for the product of these three numbers that are not necessarily distinct. So a perfect square has prime factorizations with all primes having even exponents. So 4 is a perfect square. Why? Because its prime factorization has 2 squared, and 2 here, the exponent 2 here for the prime 2 is actually even. So 8 is not a square number. Why? Because its prime factorization 2 cubed has an exponent of 3. 3 is not even. So we just want the product of the three numbers to have prime factorizations with even exponents. So this just basically tells us that. So now we use the fact that the three numbers are not all different, meaning at least two are the same. So at least two are the same. So if I multiplied any two numbers together, they are the same. So I have any number a and I have a squared. This is obviously a perfect square given that a is a positive integer, or a is an integer, right? So I don't have to worry about the two numbers. The two numbers produce a perfect square. Now I need the third number b, so I have a squared, and I want a squared b to be a perfect square. I need the third number b to be a perfect square. So for what options are my b valid for? So we know that none of these numbers are perfect squares except for 4. 4 is the only perfect square here, so b has to be 4. Okay, so we have b is 4, which means that this is 4a squared. So 4a squared is definitely going to be a perfect square. Now the question asks how many of the three players can now deduce the numbers on their foreheads after the clues we've given. So let's just pretend that we're this random player. We see the other two numbers on their forehead. 1 is gonna be a, and if 1 is a and 1 is 4, we know our number is also a. So we can deduce our number if we have a and 4. If we have 4 and a, then we can also deduce that our number is a, because one number is 4, that is the perfect square number. Our number is going to be equal to a to form a squared. So our number is also going to be a. If we see a, then these two numbers form a perfect square. We need another perfect square, so we know that our number is going to be 4. So all three students can deduce their number. So the answer here is going to be 3 students. Wait, sorry, not 3 students, all 3 players. So thanks for watching.